Good morning, and thank you for coming. Plastic is a problem. Each year, 20 billion pounds of plastic waste, that is 20 billion with a B, escape to our oceans, and they create large plastic islands. Landfills are clogged with it. Our water and air are polluted based on their manufacture, just during their manufacture. And it also contributes to the greenhouse gas effect. It's arguably the biggest environmental challenge next to climate change. And we need more of it. The truth is, we cannot live without it. Plastic is intertwined in our lives and our economy at the very basic level of everyday use. Your plastic bottles, your plastic bags, electronic gadgets, building materials, and even the toothbrush that you may use this morning. Right? And the demand for such products is increasing exponentially. Because in China, India, and Latin America, where more than half of the Earth's 7 billion humans live, more people can afford such products. By 2050, the demand for plastics alone is going to double. To meet this demand, we will need twice the raw material, and of course, far more energy to manufacture them. But the problem is, currently, these are made primarily from petroleum crude, and we know that it's rapidly depleting. So is there a way to make these products with fewer raw materials, or better yet, alternative raw materials that are more sustainable, with less energy, and at the same time, minimize pollution? That would mean we make more with less, meaning more profitable, but it will also protect human health and reduce environmental footprints. And the first steps for addressing this grand challenge are already being taken. And a major part of that solution is to make these products from renewable feedstocks such as plant-based biomass. What if I told you that Kansas can take the lead in this evolving, emerging industry, which is expected to be $100 billion by 2020, and capture easily 10% of the market? Before I do that, let me take you on a journey to tell you a story about how this potential solution came about. I did my undergraduate education in chemical engineering in India and was very fortunate to have the opportunity to come to the United States to pursue graduate education at the University of Notre Dame. My PhD research dealt with the development of automotive exhaust catalytic converters to reduce harmful emissions. It was at that time I became interested in pollution prevention. That is, in technologies that prevent or minimize waste in the first place, so we don't have anything to clean up after the process. My first introduction to such a technology was the fascinating decaffeination of coffee beans by liquid carbon dioxide. This technology was developed in the 1970s to replace harmful solvents that were being used at that time to extract caffeine from the coffee beans. Now, one such solvent is methylene chloride. It's a known carcinogen, and it also left traces in the final product. So its use had to be banned by the FDA. Now, carbon dioxide, on the other hand, we know it's a gas at ambient conditions, but when you pressurize it, it becomes a liquid and behaves very much like a household cleaning solvent. And under those conditions, it's able to effectively extract out the caffeine. And then when you release the pressure, it escapes as a gas, just like releasing fizz when you open a can of soda. Today, thousands of pounds of coffee beans are being decaffeinated using liquid carbon dioxide in vessels that are about 6 stories high. Now, that's slightly bigger than a Starbucks venti, isn't it? Yeah. So what's interesting is that the industry not only adds value to the decaffeinated coffee beans, but then they're clever. They also extract the caffeine that has been extracted out and sold that to beverage companies and pharmaceutical companies. So technologies that protect human health and the environment can be profitable as well. When I became a professor at KU, I decided to pursue the use of liquid carbon dioxide in other manufacturing processes, including chemicals. So I decided to write a proposal to the National Science Foundation. I wasn't sure if the reviewers would buy into that idea, but I was really delighted that they did. So they were equally crazy as I was, I suppose. So that grant was very critical because it enabled our research group to build an equipment in which we can test the use of pressurized carbon dioxide as solvents for various processes. Few laboratories in the US had such a capability, and this led to important collaborations at KU. The first was with Val Stella, a distinguished professor of pharmaceutical chemistry, who came to me wondering if we can use carbon dioxide to make pharmaceutical drugs without any harmful residue. Sound familiar? I was delighted at that opportunity. And we took on that challenge, and we were able to produce powders, fine powders of pharmaceutical drugs using liquid carbon dioxide as the processing medium. And they were also of uniform size when compared to the conventional technology. Most importantly, those powders did not have any residual solvent as the conventional processes do, because carbon dioxide does not leave residue on the drug. And this makes it easier for approval by the FDA, and most importantly, also protects human health. This directly led to the formation of a startup company called Creditech. It's based in Lawrence, Kansas, and Creditech is now using the technology developed in our lab to make fine powders of various pharmaceutical active ingredients or drugs, which can then be formulated to make tablets or injectables or inhalables and so on. As an example, Creditech has used this technology and produced an anti-cancer drug called Nanotax. This drug has performed very impressively in treating ovarian cancers in animal studies and also in initial human trials performed at the KU Medical Center. The company has been able to attract investment as a result, and recently also got FDA approval to test Nanotax in other forms of cancer. And Creditech expects to have products in the market. The next significant collaboration that was enabled by that particular piece of equipment was with Darryl Bush, a distinguished professor of chemistry also at KU. Professor Bush and his industrial sponsor learned of our research in the area of applying pressurized carbon dioxide for enhancing the performance of chemical reactions and approached us and wondered if they would try, or if we could do one of their problematic reactions in liquid carbon dioxide. And we collaborated with them and discovered that carbon dioxide is not only a non-toxic solvent, but it also enhanced process safety. And that was a reaction which happened to have oxygen. And whenever you mix oxygen with a fuel, you always have this risk of explosions. And having that pressurized CO2 provided that safety. After all, CO2 is what is used in fire extinguishers to put out fires, right? During the 1990s, another important thing happened, which was the US Pollution Prevention Act. That act required industries to prevent pollution at the source, reduce or prevent pollution at the source, which was very consonant with what we were trying to do at KU. What this required was new technologies for existing processes using the principles of green chemistry and green engineering. To develop such technologies, Professor Bush and I, we partnered with several professors at KU and also nationally to launch a research center which was primarily dedicated to develop green technologies. And this was started with major funding from the National Science Foundation. And that funding helped us to attract leading researchers, recruit them, and also enhance the research infrastructure significantly so that we can perform cutting-edge research in green chemistry and green engineering. Today, the mission of the Center for Environmentally Beneficial Catalysis, that's the name of the center, or for short, CEBC, is to develop technologies that are practically viable to make the chemical products from a variety of feedstocks, including plant-based biomass, while conserving feedstock and conserving energy. Several prominent companies that you see on that slide, they embraced the center's mission and became founding members of our center. Since that time, 23 members have become dues-paying members of the center, the CEBC, and they work very closely with our researchers to develop technologies that they can license and commercialize. To those who question partnering with companies with questionable environmental records, I would ask, isn't using their resources, including intellectual resources, to solve environmental problems the very thing that we should be doing? So, the mission of our center, we think, is even more relevant today than it was when we started in 2003. And that is because the demand for green products is increasing, especially among the younger generation. For example, CocaCola is now successfully marketing the so-called plant bottle. 30% of the plastic there is made from plant-based biomass in the form of bioethanol. Procter & Gamble, another major company that makes a myriad of the everyday products that we use, they have set out an ambitious agenda. By 2025, their goal is to make all of their products with either recycled or renewable materials. Very ambitious goal. And several other members of our consortium share similar strategies. Just to give you an idea, the demand for products in this industry, the market pull is giving rise to tremendous business opportunities. By 2020, the market for green products is expected to be $100 billion per year in the US alone, and it's expected to grow. But we need technologies. We don't have the technologies to make them. And the CEBC's mission directly acknowledges this need. I want to now give you an idea of a revolutionary technology that we have developed. Just an example. Everyone on this planet has drunk from, sat on, washed up with, or driven in something that's made from ethylene oxide, or we'll just simply call that EO, right? Because ethylene oxide is used to make plastic bottles, detergents, antifreeze, and also building materials. It has a whopping $30 billion per year market, and it's expected to grow. But this manufacturing process for EO has problems, as shown on that slide. When you mix ethylene, which is a feedstock, and oxygen at very high temperatures, then you end up producing carbon dioxide as well. So literally, 15% of the ethylene, the feedstock, goes up in smoke, a value of $2 billion per year. And that's because you're mixing a fuel and oxygen at high temperatures. The researchers at our center came up with a process, an alternative process, that mixed the ethylene with different ingredients that allowed us to perform the same reaction to produce the ethylene oxide at much lower temperatures without forming any CO2. So all the ethylene goes to the ethylene oxide. So we curb the CO2 emissions, and it's the second largest emitter of CO2 as byproduct among chemical manufacturing, the equivalent of CO2 emitted from 1 million cars per year. Not only that, we also conserve the feedstock, so we can use less of the ethylene to make the same amount of ethylene oxide. So this is an example of a technology that makes our industry partners accept the philosophy or embrace the philosophy that sustainability is key to a successful business strategy as well. So I've just shown you one example. There are many more examples. Our researchers have disclosed 35 inventions. 6 of them have been licensed to our partner companies. What do these discoveries mean for Kansas? Kansas is endowed with a unique mix of natural resources. Not only biomass, but also gas, oil, wind energy potential, and transportation infrastructure. So if there's an industry, we can make finished products and export them out through the transportation infrastructure that we have available. This unique mix is probably better than any other farm state. So Kansas is 4th in biomass potential, which means that they can produce the feedstock needed for producing renewable products. How realistic is this opportunity? Let's say that Kansas captures 10% of this $100 billion per year market by 2020, right? That would mean the creation of thousands of jobs, thriving agri-based businesses for generations of Kansans. That's because this feedstock, the renewable feedstock, is the only known sustainable feedstock. Once all the fossil fuels are depleted, the only feedstock from which we can make materials are the plant-based biomass that we know of today. Now, Kansas also has the intellectual assets to go along with the natural assets. The universities in Kansas and the research infrastructure are the ones that attract industries to the region. Centers like ours act as homing beacons. We already have established partnerships. Archer Daniels Midland, which is a global leader in agricultural processing, has set up a research center at KU, in Lawrence, I should say, next to our center. And they're working very closely with our researchers to develop technologies for renewable products. This industry is in its very early stage. Just imagine what it would be like for Kansas to take the lead and be at the very forefront of it. There's a real opportunity for Kansas to be a major technology developer, a manufacturer, and a global supplier of renewable products in the decades to come. But for this grand vision to be realized, there must be effective partnerships between academia, industry, and government. Our neighboring states have already begun to seize this opportunity. For example, Iowa is poised to become the first state to offer tax credits for businesses that make renewable chemicals in order to attract them to their state, obviously. As economically beleaguered as our state has been, and often viewed as lagging behind the times, fairly or unfairly, to be a leader in environmental innovation might just make Kansas a place to live, work, and be proud of, a lot more sustainable. Thank you very much.